The instruction pipeline is a key concept in computer design that enhances the efficiency of executing instructions in a processor. It involves breaking down the execution of instructions into a series of smaller independent stages, allowing multiple instructions to be processed simultaneously. From a materials science and electronics perspective, the instruction pipeline relies on the underlying physical components and principles that enable data processing in a computer. Here's a simplified explanation of how the instruction pipeline works. Number one, fetch stage. The first stage in the instruction pipeline is responsible for fetching instructions from the memory. In terms of material science and electronics, this involves the use of transistors, which act as switches to control the flow of electronic signals. Transistors can be made from a variety of semiconductor materials, such as silicon. Number two, decode stage. In this stage, the fetched instructions are decoded to determine the specific operations that need to be performed. Electronic components called logic gates, built from transistors, help in interpreting and decoding the instructions. Logic gates are assembled using semiconductor materials. Number three, the execute stage. Once the instructions have been decoded, the processor performs the necessary calculations or operations specified by the instruction. At this stage, electronic circuits such as arithmetic logic units, ALUs, carry out the desired computations. ALUs are comprised of components like logic gates, registers, and multiplexers. Number four, memory access stage. Certain instructions might involve accessing or modifying data stored in memory. In this stage, the processor interacts with memory components which can be constructed using materials like semiconductors and conductors. Data transfer occurs through buses, typically composed of conductive materials like copper or aluminum. Number five, write back stage. The final stage of the pipeline involves writing the results of the executed instruction back to the appropriate registers or memory locations. Again, this stage relies on electronic circuits and components for performing storage and data transfer operations. By breaking down the instruction execution process into separate stages, the instruction pipeline allows each stage to work concurrently. While one instruction is being executed, the subsequent instruction can progress to the next stage. This overlapping of instructions increases the throughput and overall performance of the processor. In conclusion, the instruction pipeline in computer design relies on various materials and electronic components, including transistors, logic gates, ALUs, memory units, and buses. Through the efficient coordination of these elements, the pipeline enables the parallel processing of multiple instructions, optimizing the performance of modern computer systems.